Alright, let's get started with lesson 3.02. We're still working on polygons and symmetry, part 2. Identify and draw figures with reflection symmetry and with rotation symmetry. That's our first objective in this lesson. And then next we're going to identify and draw axis of symmetry for a center or a center of rotation for a figure with symmetry. Symmetry and regular polygons. This says a line drawn through a figure so that one side is a reflection of the image on the opposite side is an axis of symmetry or a line of symmetry. And you can look right here, line of symmetry, and look, this dog's face is identical on both sides. I can see some differences, but it's a real thing. Right here, if a figure has reflection symmetry, then you can find at least one axis of symmetry in the figure. For figures with reflection symmetry, you can fold the figure along an axis of symmetry and both halves will match up. So just pretend like these blue lines right here are your fold lines. So if we were to fold this paper in half vertically, these clouds are going to match up right here. If we folded it in half horizontally, then these little clouds are going to match up. Okay, so that's reflection symmetry. Now let's talk about rotation symmetry. It says if you can rotate it around its center less than one full turn and the rotated figure looks exactly like the original figure, then you have rotational symmetry. So if I was to take this star and turn it exactly this far to where this point moves up here, that is going to be rotational symmetry, because when I turn it, it's going to look exactly the same. This right here, of course the numbers aren't going to be the same, but just ignore the numbers. If I was to turn this in any direction, it's still going to look the same. If I took this black sector, matched it up, turned it, matched it up to where this one's at, it's going to look exactly the same. So that's rotational symmetry. Now, all regular polygons, remember regular, same angles, same sides. They're all the same size. All regular polygons have both reflection and rotation symmetry. So here I took this hexagon and I drew this line just so you can see the line of symmetry, and then I turned the polygon. See, I took this side right here and I made it on top, and you can tell the polygon still looks the same. Okay, now this one says the number of lines of symmetry in a regular polygon is equal to the number of sides. Well, a hexagon has 6 sides, so if I go through and I did all the lines of symmetry here, okay, if I count those lines, there's 1, 2, 3, 4, 5, 6 lines. You don't count these down here because it's just the other half of the 6. Okay, so 6-sided polygon has 6, regular polygon has 6 lines of symmetry. Okay, the measure of the smallest angle by which a regular polygon can be rotated to look exactly like the original polygon is equal to the measure of the central angle of the polygon. So to help explain that, I drew a my hexagon here. The central angle is 60 degrees. Okay, remember we learned that in the last lesson, how to figure up a measure of a central angle. So there it is, 60 degrees. So I rotated my angle clockwise. That's what the little arrow means. I rotated it clockwise, and that's exactly the degree of rotation. Okay, let's look at some examples. It says, do not assume that the side lengths and angles are drawn to scale. Only information that is explicitly given or marked can be assumed, and that's for almost any geometry problem ever. It says, name a central angle of each polygon. Well, if you look, they're showing us 3 different angles right here. Here's one, there's one, and there's one. Well, you have to decide which one is the central angle. And remember, the criteria for central angle is it comes from the center and it goes to two consecutive vertices. Well, S and T are consecutive, so this is going to be our central angle. And here's your official answer. And look, I put in all caps, consecutive vertices. They have to be right next to each other. See how you can't go from S to W because they're not consecutive. There's an R stuck there in the middle. Okay, for this one we're going to determine the number of central angles, and then we're going to the measure of each central angle. We're going to calculate that. So if you look here, here's the center, and let's see how many central angles we have. There you go. Alright, how many sides does this pentagon have? 5. So it's going to have 5 central angles. Okay, now let's figure out what the measure of each central angle is. Remember, n is going to be my number of sides. So you're going to take 360 divided by n. N happens to be 5 because this is a pentagon. 360 divided by 5 is going to give you 72 degrees. So finding the measure of the central angle is pretty easy. A summary for this lesson: a figure has reflection symmetry if you can find at least one axis of symmetry in the figure. It has rotation symmetry if you can rotate it around its center less than one full turn, and the rotated figure looks exactly like the original figure. In a regular polygon, the number of lines of symmetry is equal to the number of sides in the polygon. And the smallest angle by which a regular polygon can be rotated to look exactly like the original is equal to the measure of its central angle. Of course, you need to be reading through the LMS lesson 3.02, Polygons and Symmetry Part 2, and completing the student guide. Remember, those are your notes that you get to use on your test. Be sure to add any notes that you can gather from reading through the reference guide, and complete the following problems in the problem set. And last time I didn't know if it was the correct problems, but I know these are, because I remember copying and pasting that information in. Please, when you get finished doing those problem sets and going through the lessons, contact me or attend TOGA if you have any questions about the concepts before you try to complete the quiz, because we want you to make good grades on the quizzes since there are no retakes or corrections on the quizzes. And that's going to be it for this lesson on polygons and symmetry. Thank you for listening.